Hello, so this is multiplying two decimal numbers. The memory card for Steve's camera measures 82 hundredth inches. Is that right? 82 hundredth of an inch. 82 hundredth inches? 82 hundredth inch, because inches would be plural. Whatever. By 1 25 hundredths of an inch, or 1 1/4 inches. What do you estimate the total area of the memory card is? So if I see this as, I'm going to be multiplying these, because when we find area we multiply the two dimensions. It's going to be inches squared. This is 1 1/4, almost 1, so I would say somewhere around 1 1/4. So a little bit less. What? 1 1/4. What's in between 1 1/4 and 1? It would be 1 16ths. So, and 16ths would be what, like 0.08 or something? I'll say 1.08. My answer is 1.80. 1.08 inches squared. Find the exact area of the memory card. Show all of your work. Fill in the array below if it helps you. So you didn't need to do this. However, I do like these a lot. So these are my pieces here. We'll have done this one point at least in class. So these are rods and pieces. And so if I have my pieces here, is that like this piece is 0.8, this piece is 0.8. No, wait, that's not right. It's separate, so it's point something or other. Anyway, I like doing it this way better. Because yeah, this whole thing is 0.8, so this is 0.8, because it's 0.8 times 1. This is 2/10 by 8/10. So if I was thinking this is as 8/10 and 2/10, that would be 16/10. No, that doesn't make sense. Yes, 16/10. Second, so 0.8 times 0.2. No, it's 0.16. It's 16 hundredths. Because, here, let me think about this. 8 tenths times 2 tenths. Yeah, 16 hundredths. I was adding them in my head. 16 hundredths as we multiply this. So yeah, that's what I was thinking. So this is 0.16. And then we have 0.05 by 0.08. So it'd be 8/10 times 5 hundredths. So that'd be 40 thousandths. Oops. 0.040. 40 thousandths. Right? See, I need to write this out here so it makes sense. 8/10 times 5 hundredths equals 40 thousandths. Yeah, okay, cool. Here, this is 2 hundredths times 1. So I'm going to write these. I don't know why I put that there. This is 2 hundredths and 2 tenths, so this is 2 hundredths times 2 tenths equals 4 thousandths. And then this is 2 hundredths times 5 hundredths. Well, that's going to be super small. What is that? 10,000. 10 10,000ths. So that's teeny tiny. I guess that would be 1,000th, right? Yeah, 1 over 1,000 would be the same as 10 thousandths. Okay, so now I need to add all these together. So I'm going to do that over here. So we have 0.8. I'm going to cross it out since I put it up there. 0.16. 0.040. Really important that you line these up right. 0.2. Oh, yeah. 0.004. 0.001. Alright, and if it helps you, what you can do, this is a decimal point here, is I can start filling in my zeros. Okay, so these are all zeros to remind me. Then I need to add all this together. If this is freaking you out, you can think of it as 800 plus 160 plus 40 plus 200 plus 4 plus 1. It's the same sort of place value. Then you would need to remember to put that decimal point there. So 0s, 4 and 1 is 5. 6 plus 4 is 10. 1 plus 8 is 9, plus 9 is 10, plus 2 is 12, and I have my decimal point. So 1 and 205 thousandths of an inch squared. What is the place value of the smallest unit of area? What is the place value of the smallest unit? Thousandths. You could say 10 thousandths if you just kept this as a 0. That would be fine too. Fill in an estimate and the exact answer for the problems below. Show your work. Okay, so now I need to take the standard algorithm, which I should have learned in Unit 5, and do this work. Okay, so my estimate here is I have 5. Let's say this is about what, 5/10 times 5/10, so that's like 25 hundredths. So my estimate is around 0.025. This is about what? This is 2 times 1.5. So 2 times 1 is 2. 2 times 2 is 4. 2 times 1.5 would be about 3. And then we have 3 and 7 hundredths times 28 hundredths. It's going to be teeny tiny. It's going to be less than 3.7. Oh, if I think about around the 10th, it would be 0.37, so double that. Well, 0.7 somewhere, 0.6. How about 0.75? Alright, so let's go to work. So again, we go right to left, and then the thing we have to remember about the decimals is we have to move them over or add them here. So same process as my algorithm. 6 times 0 is 0, 6 times 4 is 24, 6 times 0, so 6 times 0 is 0, 6 times 4 is 24, here's my 4, my 2's up here, and then 6 times 0 is 0, plus 2 is 2. We do not bring down any decimals at this point. This isn't how this works. This is why your estimate's so important, because if you put 2.4 right here, look, it's way over the estimate already. Okay, so now we add my 0 down here, or we write the 0, sorry for that, and then we have 5 times 0 is 0. And then 5 times 4 is 20, so I have my 0 and another 2, and then 5 times 0 is 0, plus 2 is 2. Oh yeah, that makes sense. Oh no, sorry, I shouldn't have put that there. Ignore that. That was, I don't know what I was thinking. 0 plus 0 is 0. 4 plus 0 is 4. 2 plus 0 is 2. And bring that 2 down now. Here we go. What was my estimate? My estimate was 0.25. Where am I going to put the decimal point? I'm going to put it here, and the reason why is I have 4 place values involved to the right of my decimal points. So I count those up: 1, 2, 3, 4, and here it is. My decimal point goes 1, 2, 3, 4. So my exact answer is 0. Sorry, 0 and 2,240 ten thousandths, or 224 thousandths. This is why it's really important to estimate. Really important to think about things. You can't just rely on the algorithm, because especially with this one, what are you going to do here? Okay, you have to have some sort of understanding. Alright, so we have 2 and 6 hundredths times 1 and 42 hundredths. So again, I just multiply. 2 times 6 is 12. Carry that 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. Go to the next one. Have my 0 there. 4 times 6, is 24, carry the 2, 4 times 0 is 0, times 2, plus 2 is 2, 4 times 2 is 8. We need 2 zeros, because we're looking at this, and then it's just by 1, so I can write that number down, 6, 0, 2. So if you're struggling with this and keeping things lined up, get yourself some notebook paper and turn it sideways, and then like this. Do I have any notebook paper? Hold on. So again, if this is a struggle for you, then rewrite it on notebook paper. So I have 2.06 times 1 and 42 hundredths. And then I use my lines here to keep track of stuff. So 2 times 6 is 12. 1, 4, I have my 0 here. 4 times 6 is 24. It's going to be 2, and then 8. And then I have 0, 0 on my 1, 6, 0, 2. So I've lined everything up nicely. So if you're not able to do that freehand, use this, because place value is super important. Okay, so now I add 2 plus 0s is 2, 1 plus 4 is 5, 4, I see my 10 combination, and 2 is 12, 1 plus 8 is 9, and then 2. So where do I put my decimal point? Well, remember, my estimate was 3, so it's going to go here. And I know that too because I have 4 place values to the right of my decimal point. 1, 2, 3, 4. I go 1, 2, 3, 4. Okay. This is when I start to get uncomfortable. I have to shift things around. Alright, 8 times 7 is 56. 8 times 3 is 24, plus 5 is 29. 2 times 7 is 14. Carry my 1. 2 times 3 is 6, plus 1 is 7. And that's all I had to do. 6 plus 0 is 6. 9 plus 3 is 13. 1 plus 2 is 3. Plus 7 is 10. Oh, sorry. So I put my decimal point here, even though I thought of this wrong. I see this now, like this is almost a third and this is 3, so a third of that would be around 1, I'm guessing. But again, how many spots to the right of the decimal point do I have involved in this? I have 1, 2, 3. So my decimal point goes 1, 2, 3. Let's put that. Oh, sorry. So my exact answers here are 2 and 9, 2, 5, 2, and then 1 and 36 thousandths. All right, bye.